You know that feeling when you're wrestling around behind your TV trying to get just a standard 10-foot HDMI cable to give you a clear
Oh
picture?
yeah, you jiggle the wire and the whole screen flickers.
Right. It feels so incredibly fragile. I mean,
Right.
it's totally binary. You either get this flawless picture or you're just staring at a blank screen with that annoying no signal message.
And, well, that fragility is exactly why the pro audio-video world operates by a completely different set of rules.
Yeah, so today our mission on this deep dive is to decode some high-end commercial hardware. We really want to understand how flawless 4K video can travel, seemingly impossible distances.
We're looking at the spec sheet for the Kramer 676R AV receiver from HDTV Supply, right?
Exactly. And it really shifts your perspective. Just imagine taking that fragile 10-foot signal you fight with at home and blasting it across an entire city instantly.
It completely redefines what we think of as a long cable run. I mean, we're talking about guaranteed signal integrity over miles of terrain.
Okay, let's unpack this because the sheer numbers on this Kramer 676R are just staggering, like it's a long highway commute.
It really is.
This little box receives 4K video at 60 hertz, keeping the full 4.4.4 chroma, and it does it from up to 33 kilometers away.
Which is about 20.5 miles using single-mode fiber optics, or 3 kilometers on multi-mode fiber.
Right. But wait, I am stuck on the math here. An uncompressed 4K signal is a massive 18 gigabit per second data stream.
Yep, it's a huge amount of data.
But the spec sheet says this uses a 10 gigabit optical link. I mean, that is 18 pounds of data in a 10-pound bag. How does it travel 20 miles without arriving as a pixelated, lagging mess?
What's fascinating here is the active conversion technology happening inside the device. Uses this near-zero latency video chroma subsampling.
So kind of like compressing a file.
Exactly. Think of that raw video signal like a heavily packed suitcase. The chroma subsampling acts like vacuum sealing your clothes.
Oh, wow, okay.
Yeah, it compresses the color information just enough to squeeze that 18 gigabit signal into the 10 gigabit fiber optic pipe.
So it's shrinking the color data down for the journey, but keeping the actual resolution completely intact.
Precisely. And then it unpacks it so flawlessly on the other end that the human eye literally can't spot the difference.
That makes sense. So that full 4.4.4 chroma spec just means the final unpacked image doesn't suffer from color smearing.
Right, you get visual perfection without any noticeable delay. And it does this whether you're using single-mode fiber.
Which shoots that single laser beam straight down a tiny core for those massive 20-mile distances, right?
Yeah, exactly. Or you can use multi-mode, which bounces wider light beams for those shorter local runs.
But, sending a perfect signal 20 miles is really only half the battle. Like, if you own a massive sports bar, having the video arrive is totally useless if the TVs are off.
Oh, or if they're displaying the wrong aspect ratio.
Exactly. And looking at this hardware, I mean, it's a really slick, fanless aluminum enclosure. It clearly can't just be a dumb receiver. It has to act as a smart controller.
Yeah, that is where features like bidirectional RS-232 come into play. It's essentially an old-school but ultra-reliable communication channel.
Meaning data flows both ways.
Right, it allows the display to talk back to the controller and vice versa.
Got it. And it pairs with that CEC feature, which automatically powers the displays on when a presentation starts.
And shuts them off when idle to save energy, which is huge.
Yeah, you definitely don't want someone running around a corporate campus with 50 different remote controls.
No, definitely not.
And speaking of 50 TVs, the specs highlight a multi-drop capability. So rather than having a massive switchboard sending individual signals to every screen...
You don't need all those bulky distribution amps.
Right, so is it acting more like a prism? Like you shoot one beam of light and physically split it out to all those screens?
That is the perfect way to visualize it. You just use simple optical splitters.
Just splitting the light directly.
Yep, just splitting the light. And to make sure those 50 TVs actually know how to display that light, it uses IED Pro.
Which manages EDID, right? The digital handshake between your video source and your screen.
Exactly.
Ah, the handshake. The invisible negotiation that fails when my living room TV just gives me static.
We've all been there. But the Kramer actively manages and processes that handshake to force it to work. It ensures instant plug-and-play without those annoying display errors.
That is incredibly smart.
If we connect this to the bigger picture, all these smart features, combined with an $820 price tag, create highly cost-effective and easily troubleshooted networks.
So if something goes wrong, you don't need an engineering degree to fix it.
Right. You just check the local LED indicators for power, source, and fiber links to fix issues in seconds.
So bringing this back to you, the listener, understanding how commercial tech like the Kramer 676R Manages multi-drop signaling and intelligent ED'd handshakes.
It really sheds light on why our consumer-grade setups can be so finicky.
It really does. At home, we are relying on passive copper cables, just hoping the signal makes it.
While the pros are using active, intelligent fiber systems to actually guarantee it does.
It's the difference between crossing your fingers and having absolute control over the data environment.
Totally.
Which leaves you with a pretty interesting question to ponder. If commercial tech can shoot a flawless, uncompressed 4K video signal 20 miles using a single beam of light today,
Yeah.
well, maybe the reason we are still wrestling with 10-foot copper cables behind our TVs isn't a limitation of technology, but a limitation of the consumer market.
Oh, it's a good point.
It definitely makes you wonder how long until traditional copper HDMI cables become entirely obsolete in our own living rooms.